Hello, Year 11s. Hello again. I hope you're all well. This video is going to go through the next section in your working from home booklets on graphing parabolas. In this one, we're actually using the quadratic equation. I realized I wrote it wrong here, so let me erase that. We're using the quadratic equation to help us graph quadratic functions. Now in the first two parts, what we did was we first factorized our quadratic and used that method to graph a quadratic function. Then we used the completing the square method to graph a quadratic function. This time we're actually using we're going to focus on the different parts of the quadratic function quadratic equation that will help us actually graph a quadratic function. So here we go. Let's just recall what the quadratic function tells us. Now, we did this in algebraic techniques when we were factorizing a quadratic function, but basically what the quadratic function told me was that if I had a quadratic function, or quadratic equation, it told me that if I had a quadratic function that looked like this, f of x is equal to ax squared plus bx plus c, I could tell what the zeros are for any quadratic function using this equation. So the equation was, if you remember, x is equal to, and I'm going to color code it, negative b plus or minus square root, I'll make that square root a little better, b squared minus 4ac over 2a. So if you remember, this is what we looked at when we were doing algebraic techniques. If I substituted values of b, a, and c into this equation, I would be able to find the zeros or the solutions of my quadratic function at for any quadratic function. Doesn't matter what it is, I will always get the solutions of it. Now what we're going to do is in this section, we're going to break this equation down into two parts. And these two parts are actually really important parts that will help us to graph a quadratic function. So what I'm going to do is I'm going to just break it down into these two parts. So here, if you have a look at the equation, the first part that we're going to look at is the axis of symmetry. Now, if we were given an equation of, so I'm just going to write here, axis of symmetry. If we get given the equation of a quadratic function in this form, so this one over here, and we can use this quadratic equation, the first section over here, I'm just going to highlight it in, let's do it in yellow. This section here, this b over 2a, that's actually the equation of the axis of symmetry. If you ever wanted to find the axis of symmetry really quickly, what you could do is you could go x is equal to negative b over 2a. So negative b over 2a will tell you what the axis of symmetry is. Now, if you remember when we were graphing a quadratic function, once we found the axis of symmetry, we could also then immediately find another really important aspect of the quadratic function or the parabola that we're graphing. If you remember, what we could do is then, if we're trying to graph our quadratic function, we need to sub the axis of symmetry to find our vertex. So here, the important thing to note is that the equation for the axis of symmetry is this negative b over 2a. So I'm going to highlight it. Negative b over 2a gives you the equation of the axis of symmetry. So the first part of our quadratic equation, if we just take that first section, that negative b over 2a, that gives us the axis of symmetry of our quadratic. So here I'm just going to draw it so it's a little bit, so you can see it visually as well. So if I have my quadratic like here, this thing here, that line is just x is equal to negative b over 2a. Okay, hopefully that's cool with everyone. The next part that I'm going to highlight is this little section inside the square root. This little section inside the square root. I'm going to highlight it in a different color. I'm going to highlight it in, let's go pink. Oh, that's a little bit hard to read. Okay, I'm just going to do it in green. Okay. That's also hard to read, but oh well. That section inside the square root has a very special name. Now this is called the discriminant. Discriminant. And in maths, we shorthand it. We use a Greek letter to represent it. So we use a big triangle. This is called delta or capital delta. I'm just going to make that D a capital just to note that we are dealing with capital delta. And this discriminant section, so that b squared minus 4ac, that tells us, so indicates how many real roots exists. So this tells me how many real roots exists. So here I'm just going to write it down underneath. Discriminant is equal to b squared minus 4ac. Now, when we're talking about how many roots, the way that we can tell how many roots exist is by looking at what value the discriminant gives us. So there's three conditions here. So here we go. Let me just go through what these three conditions are. So when we're looking at the discriminant can either be greater than 0, the discriminant can be equal to 0, or the discriminant can be less than 0. Now here, if the discriminant is greater than 0, that tells me that there are 2 real roots. Now if I was drawing this on a quadratic, what do the roots correspond to on my quadratic? Well, the roots are just your x-intercepts. So if I was drawing this as a quadratic, what it would look like is I have my quadratic here, and I have 2 x-intercepts. So it looks something like this, for example. So here I've got 2, 1, 2. I've got 2 real roots, or 2 x-intercepts. Now the next condition is if the discriminant is equal to 0. So if the discriminant is equal to 0, that tells us we only have 1 real root. And once again, let me just draw on the side what that would look like. 1 real root would look something like this. My quadratic just touches the x-axis at one point, and so we only have 1 x-intercept. And the final one is the discriminant is less than 0, and hopefully you'll notice there's a pattern here. So 2 real roots, 1 real root. When the discriminant is less than 0, there's no real roots. And so my parabola, or quadratic function, I'm going to draw it down here because I don't have much room there, will look something like this. So it doesn't actually touch the x-axis. So here, the second important part to note is the discriminant. The discriminant tells me how many real roots my quadratic has. So we have to look at, once we've found what the discriminant is, then we also check the conditions on the discriminant. Is it greater than 0? Is it less than 0? Or is it equal to 0? So here, these are how the parts of my quadratic equation can actually help me find important information that I need in order to graph my quadratic function. The first part is I can just easily read off my axis of symmetry by subbing in x is equal to b over 2a. I sub in that value back into my quadratic to find me the vertex. And the second part is checking the discriminant. So the discriminant will tell me whether or not I'll have 2 roots, 1 root, or no roots at all. So what I'm going to do now is I'm going to go through a few examples with you to show you how we can apply these steps in graphing a quadratic.